Geographic coordinate systems, we're concerned with longitude and latitude. If we look at the Earth spinning on its axis, there is a line that cuts through the center of the Earth, which we call the equator, which is halfway between the North Pole and the South Pole. This is a natural line of 0 for latitude. As we're measuring higher latitudes, such as this point up here, we don't measure that as a distance, but we kind of think about it as starting at the center of the Earth. And then if we drew a line that went through that point on the surface of the Earth, what sort of angle would that be from another line that comes out right at the equator? And in this case, it would be a 45-degree angle. So that would be a latitude of plus 45 degrees or 45 degrees north. For longitude, there is no intuitive line of 0. So we just chose one. The 0 line of longitude goes through, is called the prime meridian, and it goes through the Greenwich Observatory in England, and that's what we all chose as a line of 0 longitude. Going to the east from that line, we get into positive longitudes, and going west towards the United States from that line, we get into negative longitudes until we meet back up at 180 degrees around on the other side of the Earth, on the complete other side of the Earth. So in this example here, this point right here, if we do a line from the center of the Earth through that point, we can see that's made an angle of about 30 degrees between the 0 line of longitude, or this line that goes through the 0 line of longitude, and this line here that goes through our chosen point on the Earth. And we can see that because we're moving towards the west, we make that a negative 30 degrees, or we could say that's a 30 degrees west line of longitude. So one thing to keep in mind is sometimes instead of reporting these longitudes and latitudes as degrees and minutes and seconds, where each degree can be divided into 60 minutes and each minute can be divided into 60 seconds, sometimes we use something called decimal degrees. And a decimal degree would just be the latitude that you're at, for example, let's say 44 degrees, and then everything after the decimal point would just be where you were between the 44th and 45th line of latitude. One important thing to remember with this is we want to keep a lot of decimal places if we do this, because we want to keep at least 5 to 6 decimal places, because if we just stop after 3, that gives us uncertainty of about 110 meters. But if we can get it out to the 6 decimal place, then that's within 0.1 meter, which is a pretty good estimate of where we are on the surface of the Earth. And we can also use degrees, minutes, and seconds. They can give us better accuracy, but when we store those in the GIS, they're just converted into decimal degrees anyway. So we really want to be certain that our decimal degrees have enough decimal places in order to best capture that location on the surface of the Earth.